Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a concrete filled steel tube, that is CFST column. We will start by double clicking on static structural module. We will first go to engineering data. Now we will add two materials. Concrete M30 is the first one. We will give the value of density 2300. Then we will give the property of isotropic elasticity. The value of Young's modulus in megapascal is 25 and Poisson's ratio is 0.18. Also, we'll give the value of compressive yield strength in megapascal. This is 30. We'll add one more material, that is steel. This is Fe250 that I'm added. We'll first get the value of density, which is 7850 kg per meter cube. Also, we'll give the value of isotropic elasticity. Young's modulus is 200 gigapascal. So this is 2E9 in terms of Pascal, and Poisson's ratio is 0.3. Go to project and update project. We'll go to geometry and right click. New design modular geometry. Units will select millimeter, XY plane, look at. We are going to analyze for a circular CFST column. So we will start by going to the sketching and choose circle option. We'll first draw a circle. We'll give it dimension. This is the inner part of the column, which will be made of concrete. So this is of 480 mm diameter. We'll click on look at option. Then we'll go to modeling, extrude. We'll select the sketch 1, apply. You will give the depth as 3 meters, so that is 3000 mm. Then we'll generate. So you can see here. Then in XY plane, I'll create another sketch. Sketch 2. Click on look at. I'll go to sketching again, and this time I'll make the outer hollow tube, which will be of steel. So I'll use circle option. I'll draw this circle. It will be overlapping this one, and then another circle. I'll give it dimension. This is 500 mm. Then I'll go to modeling, extrude, select sketch 2. Depth is 3000 mm. Operation, instead of add material, I'll choose add frozen and generate. So you can see here now. This outer portion will be the steel tube, and this inner portion is concrete. So you have concrete filled steel tube, CFST column. So once this geometry is done, we'll close it. We'll go to the main screen, model, double click. We'll first go to geometry, select the solid. This is the inner solid. So I'll give the material as concrete M30. For the outer solid, I'll give the material as just simple steel. Then we'll go to mesh, and here I'm going to change the sizing a bit because I'm using the student version. So I'll just select unit meter. I'll give the size as 1 and generate. So you can see here, this is generated over the column. You can give a fine meshing if your software supports. Mine will not, hence I have given a little coarse mesh. Now I'll go to static structure, right click, insert, pick support. I'll select face option. I'll select both of them, apply. On the other end, I'll select and insert force. This is along the z-axis, so I'll change vector to component. I'll give this value as, say, 10 kilonewton. We'll hold this vertical. Now I'll go to solution, right click, insert deformation total, insert deformation directional. I want to see along the z-axis. Also I'll insert strain equivalent and the stress equivalent. I'll go to solution and solve. So we'll see the solution. First is total deformation. I'll change edges to no wireframe such that it is very clearly visible. Also, I'll go to contour and select smooth contours. So now we'll first go to total deformation. We'll see the maximum deformation is 0.0012 meter. You can convert this into mm also by changing the unit. It is 1.2 mm at this end. If you want to see where it is max and min, click on max min. You can see the maximum deformation and the minimum deformation. Minimum is 0 because here it is fixed. Then we'll see the directional deformation. You can see the maximum value is 1.1996 mm at this end, and at the lowest position it is minimum 0. Then we'll go to equivalent elastic strain. Maximum value is 0.0019 and minimum is 6.92 into 10 raised to minus 5. Then we'll go to equivalent stress. Maximum is 1.0357 over here and minimum is 0.004 megapascal. Now these values are too less as compared to the value of yield strength of concrete or steel. Hence the column is completely safe. If you want, you can increase this value of load that we have given and you can test for higher values. When you see the deformation has exceeded too much, or you can see the value of stress has exceeded and it is close to the yield strength of concrete, which is obviously lesser than steel. So you should obviously focus on yield value of concrete, not of steel. And when you see that this value of stress is closer to that value, then you can say that it is the maximum load it can take. Currently, it is very safe under this 10 kilonewton load. You can increase the load and you can check. Now, what is the advantage of using CFST column? We have also analyzed for circular concrete column, and here we are seeing the column which is of steel material and it is filled with concrete. What happens is when you use only concrete, concrete has a lesser value of yield. Here the load is shared by the steel and the concrete material both. Also, the yielding of this column will be much lesser or it will be much slower as compared to a complete concrete column. So this is a new technology which is used wherein the concrete columns are now covered with a steel tube, or you can see a steel tube is created and in that you pour concrete and you make the column. So this gives a more load bearing capacity to the column. So the buildings in which you're going to use these columns are going to be much safer and the life of the building is also going to increase. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.